Before we start analyzing and comparing multiplication and division, let's discuss their basic definitions and some helpful vocabulary. Multiplication can be defined as combining multiple sets of equal groups together to create a product. A product is the name for the answer of a multiplication expression. There's a key word here, equal. Equal is key for division and multiplication, so watch that throughout this lesson. Division can be defined as separating one value into equal groups to create a quotient. The quotient is the name for the answer to a division expression. Factors are values that can be multiplied together. So 3 times 2 equals 6. 3 and 2 are our factors. They're very specific values because they're part of a very specific operation. Multiplication and division are inverse operations, meaning they do similar activities but in opposite ways. So when we visualize them, it helps to look at them together. They're going to act similarly, but one's going to bring equal groups together and one's going to break into smaller equal groups. Multiplication expressions have 2 or more factors that represent how many equal groups and the magnitude of each group. So let's analyze that. It's going to tell me how many groups I have and the size of each group. So 4 times 3. 4 is how many groups I have. So I'm going to visualize 4 separate groups. Inside of each group, the magnitude, the size, the value of each of those groups is 3. So I have 3 in the first circle, 3 in the second, 3 in the third, and 3 in the fourth. If I counted all those circles out, I'd end up with a total of 12. So 4 times 3 is 12. The commutative property of multiplication, which also applies to addition, allows these factors to be reversed. So 4 times 3 is the same as 3 times 4. So I could have 3 equal groups, and the magnitude of each group, or the value of each group, is going to be 4. So I'm going to have 4 dots in each group. If I go through and count out all of the red dots, I end up with a total of 12 again. So 4 times 3 is 12, 3 times 4 is 12. Division expressions represent a larger value, which we would call the dividend. This is also the first value. This doesn't have to be larger, but in most traditional ways of thinking of division, you've probably seen it as the larger value. This is equally separated into smaller equal values. The key word is equal. We're taking and dividing it, sharing it equally. The number of equal groups is known as the divisor. So I have 12. That's my dividend. I'm dividing it into 4 equal groups. That's my divisor. So I'm going to draw out those 4 equal groups. You can think of this as dealing out a deck of cards. In each group, I'm going to put 1 until I'm completely out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I stopped at 12. If I had more, I would have kept going. If I didn't have 4 more, I would have had a remainder of less than 4. Order matters in division expressions. You cannot reverse the dividend and the divisor. Just like subtraction, you can't change the order unless you turn it into addition. Division's the same way. 4 divided by 12 is a different problem than 12 divided by 4. Multiplication and division are directly related to addition and subtraction. Multiplication is just repeated addition. Division is just repeated subtraction. So if I were to look at 4 times 3, that's 4 sets of 3. So I have 3 plus 3 plus 3 plus 3 4 times, giving me 12. Likewise, because multiplication and addition both share that commutative property, I could do 4 times 3 or 3 times 4. If I add 4 plus 4 plus 4, I still end up with 12. In order to do repeated subtraction, I would look at something like 12 divided by 4. So I would start at 12, and I'm going to subtract 4. 1 time, 2 times, 3 times, until I get to 0. There's 3 steps I had to take, 3 sets of 4. So 12 divided by 4 is 3. Now, this method, again, is great for understanding how multiplication and division work, not necessarily for calculating multiplication and division. The relationship between multiplication and division can best be seen in fact families. Now, addition and subtraction exist in fact families as well, but multiplication and division are oftentimes more important, partially because multiplication is one of the few sets of values, the few sets of facts you'll ever have to memorize when it comes to algebra. If you think back, you've probably done mad minutes, times tables, etc. What you were really studying was fact families. Multiplication and division, as we've said before, are inverse operations. They act in similar ways, but opposite. Every single multiplication or division equation can be written as 4 different members of a fact family. So let's take 12 divided by 3 equals 4. That's one of the members of our fact family. I could also, instead of taking 12 and breaking it into 3 equal groups, I could take 12 and break it into 4 equal groups. There's 2 division facts here, and we're going to need 2 multiplication facts. It's going to utilize the same exact values, the same exact factors. 12 divided by 4 is 3, so likewise, 3 times 4 is 12. Because we know of the commutative property of multiplication, 3 times 4 is equal to 4 times 3, which also equals 12. Let's try 7 times 3 equals 21 and put together our whole fact family in our nice little house here. 7 times 3 equals 21. Well, according to the commutative property, 3 times 7 also equals 21. That means that I have 3 equal sets of 7 for a total of 21. If I take that 21 and break it into equal sets of 7, I'll have 3 in each group. Likewise, if I take 21 and break it into 3 equal groups, I'll have 7 in each group. Go ahead on your own, try 18 divided by 9 equals 2, and find the rest of that fact family. We usually would think of multiplication and division as being more challenging because we learn it after addition and subtraction. But luckily, when it comes to determining the sign of multiplication and division problems, it's a lot simpler. The rules are much more straightforward. In any multiplication or division expression, the sign of the product or quotient, which remember again are the names of the answers for multiplication and division expressions, is based on how many of the factors or dividends/divisors in the expression are negative. So as opposed to addition subtraction, where we had to look at the sign and the magnitude of the value, here we only have to look at the sign of the values, which makes life a lot simpler. An even amount of negative values in an expression gives a positive answer. An odd amount of negative values gives a negative product or quotient. So, a lot of teachers and a lot of students tend to overgeneralize this rule and say that when you have same sign, it's positive, opposite sign, it's negative. Instead of that, which will work, consider even, positive, odd, negative. The same sign, opposite sign rule only works if you have 2 factors or just a divisor and a dividend. We'll see an example of that in a moment. So let's look at negative 8 divided by negative 2. Looking at that, I see 2 negative. I see a negative divisor and a negative dividend. Both negative, even amounts. So my answer is going to be positive no matter what. Let's practice visualizing. I have 8. I'm breaking it into 2 separate groups. 1 for you, 1 for you, 1 for you, 1 for you, until I hit 8 total. There's 4 in each group. I already established that my answer is going to be 4. And it's going to be positive. Negative 4 times positive 5. Well, I see 1 negative, which means it's an odd number. Odd number of negatives gives me a negative answer. So no matter what, my final product here is going to be negative. I'm going to put together 4 sets of 5, 5 in each group. When I count them all out, I'm going to end up with a total of 20. But think back, at the very beginning of this problem, I predicted, based on the number of negatives, the number of negative factors, my answer has to be negative. I walked into the problem knowing the sign, and at the end, I double-checked the sign. Be very careful. Signs are where students make mistakes. We assume addition, subtraction, multiplication, division are simple because we learned them ages and ages ago. But we did not learn negatives as strongly as we always should have. Let's try a couple more. Negative 15 divided by negative 5. Well, I have even number of negatives, so my answer is going to be positive. This is a nice little calculator moment. I'm going to end up with positive 3. Negative 2 times negative 3 times negative 1 times positive 2. This is where the rule really pays off. I have 3 negatives. That's an odd number of negatives. You can't talk about whether they're opposite sign, same sign here, because I do have positive and negative factors in the same expression. I need to look at how many negative factors there are. I have an odd number, so my answer is going to be negative regardless. So I could take the time and multiply each one accounting for the sign. Negative 2 times negative 3 is positive 6. Positive 6 times negative 1 is negative 6. Negative 6 times positive 2 is negative 12. Or I could just multiply all of their absolute values together, knowing that my answer is going to end up negative regardless of what I do. This, again, is a great calculator moment. Always challenge yourself to try these by hand, but it never hurts to check with a calculator. This lesson was more to understand how multiplication division work and how you determine the sign of a product or a quotient. When it comes to multiplying or dividing larger or multiple digit values, there are a lot of tips, tricks, and methods out there that you may have learned. It all comes down to personal taste. In your own words or in your own work, answer these 2 think, pair, share problems, and we'll discuss the multiple methods another time.